This is Tom Rosberg. I'm here with Noah from ISWEP. We're going to do one more video here for a webinar on invasive plants. We are located this morning in Johnson County at a site called Chia Fan Preserve. It's owned by Johnson County Conservation Board. As Noah pans around, you can see there's some beautiful large savanna oaks here. These are probably black oaks from what I can tell. This is a sand deposit area, wind-blown sand deposit on the east side of the Cedar River, not too far from little town of Sutliff. We're going to try and see what we can find here for invasive plants, but you know, this is the fourth one now, and we've seen a lot of invasive plants. I think what we'll do, just to kind of make it more quick and simple, is we'll just do some hiking around. We'll stop at certain spots and we'll just take a look at what we can find. Some of the plants will be non-native, and maybe they'll be invasive or not, but basically this will be more of a little webinar on late season plants, probably what we find blooming in late September, things like asters and goldenrods, some of the other late species. Okay, we're going to start with some of the goldenrods. Again, the goldenrods we have in Iowa, there aren't any that are non-native or really that invasive. They can be somewhat of a problem though in restorations, in that they can be aggressive and kind of start taking over areas. So again, having some ability to tell which goldenrods you have might be helpful. There are probably three species that kind of stand out as being pretty common in open habitats, grassland environments, reconstructions. All three of them are native, and they are fairly tall. So we're looking at one of those three right here. They have this plume-like inflorescence. So among the goldenrods, there are some that have this plume-like flowering structure, or there are some that have more of a flat top structure. So we can divide them into two groups on that basis. The three that we're going to be talking about, again, have this plume-like structure with kind of arching branches. They also have three main veins. I don't know if Noah can zoom in enough to see the three main veins. They have the central vein, and then there's two lateral veins there that stand out fairly strongly. So there's three main veins. They're called triple-nerved or triple-veined species. So we're talking about those three species that have those two characteristics. One of them is giant goldenrod, and we don't see that here. It's a little bit more of a wetter soil species. But the way to start with these is to look at the pubescence on the stem, see if there's pubescence on the stem, and then look up into the inflorescence up here where the flowers are and see if there's pubescence or hairiness in here. Giant goldenrod will have hairiness up in here. There'll be hairs up in here on these branches, but there won't be any down here. The stem will be glabrous. Let me just check to make sure which one we have here. Yeah, there are some hairs on the stem here, so this is not giant goldenrod. It's one of the other two then. The other two species have hair on the stem, and they have hair up here. When we try to separate those two species, it gets a little bit more difficult. Those two species are Solidago altissima, a tall goldenrod, and Solidago canadensis, Canada goldenrod. What I always have to do is, if it's one of those two species, I just pluck one of these branches off, or just part of the flowering structure up here, and take it home with me, because the best way to separate those two species is to take one of the little flowers here, the flower heads, and look at the disc florets that are in the center of that head, and measure the length of the corollas, the petals. And if that corolla is 3 millimeters or more in length, that's going to be Solidago altissima, the tall goldenrod. If it's smaller than that, then you've got Solidago canadensis. Another way to kind of get a rough idea, and it's hard to tell again what the size of those corollas are, even with just a hand lens out here. That's why I take them home and put them under a scope. But just looking at the leaves here, it looks like this might be altissima, because when you look at the leaves here, there are some teeth, but they're very weakly developed. So it's very weakly serrate. The margins of these leaves, there's some tiny little teeth, and there's not very many of them, they're not very big. So again, Solidago altissimus tends to have teeth on the margins of the leaves, but they're very, very fine, very small teeth. Solidago canadensis leaves have teeth as well, but they're more conspicuous and larger. So that's 3 of the more common goldenrods that we might see out here. Again, not sure, but I'm guessing this one is tall goldenrod based on the leaves. Well, let's see what else we can find growing right here amongst us. There's some asters here, another important species this time of year. And this one right here is a very common one called frost aster, Aster pilosus, or the new name in Florida, North America is Symphyotrichum pilosum. So when you get into the asters, of course, things can get challenging. This is obviously one of the white asters, and it's also one that has a lot of branching. We can look at a little bit more of the plant here. You can see how much branching this plant shows. So when you do the white asters, the thing that's probably most similar to this one that you might confuse it with would be heath aster. Heath aster is Aster ericoides. They both have white flowers. The ray flowers are white. Heath aster has smaller flowers. Frost aster has a little bit bigger flowers, so there's one difference there. You can kind of get a sense. These are a little bit bigger than heath aster. The best way to be sure about things is to take a look at the involucral bracts, which are these little green structures that sit right below the ray flowers. There's a series of little structures called involucral bracts right there. And what I'm looking at, when I look at those, to sort of clarify and verify this is frost aster, is the tips of those bracts. On frost aster, the tips of those bracts are enrolled a little bit, so the top portion of those bracts towards the tip curves or rolls inward, making a little bit of a short little tube, you might say, at the very tip. Also, the whole involucral bract tends to have a shape that is described sort of as an urn, so kind of a broader base, and as you go up, it kind of becomes more narrow. So again, that's some of the couple of the characteristics that help. I think frost aster is generally somewhat of a weedy species. It can be, again, it's a native species, but it can be pretty aggressive in terms of reconstructions. I have a prairie reconstruction at home that I just mowed a large portion of it because it was just chock full of this stuff. It was really dense. The frost aster was very, very dense, very thick. It came up on its own from the seed bank, and there's way too much of it. So because it's in flower right now, this was a good time to mow it. All right, so Cheetah again is where we're at, and this is a habitat again that's dominated by a lot of sand. It was historically partly savanna and partly prairie. So what we're looking at here is mostly species you'd find in those kinds of environments. We're going to take a look at some things again we see right down here in front of us. I did find one species that is non-native. I'll pluck a leaf here and pull it up here so you can get a better look at it. So this is one of the basal leaves, and it's a pretty easy one to recognize because of the palmately compound leaf. These are all leaflets here, and they of course are arranged what we call palmately because they all come to a common point where they are attached. Maybe you can kind of see in the light there as I move it around, there's some pubescence. I can kind of see that some silvery hairs on the surface of those leaves, so it's got some pubescence. There's the back. It's got very clear serrated margins there, very strongly and fairly coarsely toothed margins. This is called sulfur cinquefoil, Potentilla erecta. Potentilla erecta is a species that's not native to Iowa, and you find it out in pastures and grasslands, degraded prairies. I would say that it's pretty harmless as far as its aggressiveness goes. I would not really put it into an invasive species category. And again, one thing to think about, I mean, I'm certainly not in favor of protecting non-native species, but this one is one that doesn't probably do too much damage other than taking up a little bit of space. All right, and we don't have any flowers of it to show you, unfortunately. We're going to look at a couple other species here, or maybe 3 more. Since again we are in an area where grasslands are kind of a dominant system, I thought I'd just pull up a few grasses here real quick and show you some grasses that are common out here. This one here is a panic grass, Dicanthelium, and with the size of the leaves, and if I take a peek at the ligule here with my hand lens, I'm pretty sure this one is Dicanthelium oligosantes, which is Scribner's panic grass. The panic grasses are native cool season grasses. There's several species in Iowa, but this is probably the most common one you would see in again these pasture grassland types of environments, older degraded prairies. Another grass that is kind of specialized and one that you don't see all the time, but we see in sandy habitats such as we're in right now, or other drier, low fertility types of environments, is this one right here. And this is a warm season grass. We can tell that again because it is right in the midst of producing its flowers and fruits here. This one is called Paspalum cetaceum. And again, it is a species that's typically only really found in drier environments, low fertility environments. A sandy environment such as this, of course, creates an environment that is somewhat drier because of the higher porosity of the soil, and any kind of precipitation or rain will percolate down through the soil more quickly. The soil can't hold onto the water quite as well as a more loamy soil. But you also should realize that sandy environments, sandy soils also usually have a lower fertility as well. So Paspalum, it's a pretty easy one to recognize. Another common name for it would be bead grass, because when you look at the fruits here and the flowering structure, it looks like a series of beads. All right, that is Paspalum cetaceum. Another one that I've seen quite a bit of as we've walked around this morning here is this one right here. And this would be one, again, that you would find in these kinds of environments. Again, an environment that, again, has a grassland history, a native grassland history, some type of prairie, but probably has a heavy grazing history as well, as this site undoubtedly has. It was heavily grazed, I'm sure, when it was privately owned. And this is horse nettle. One thing that grazing does is it helps to increase and favor the species that we call grazing increasers. That means the species is benefited by the grazing. And these are typically species that have some type of sharp, pointy structure, as the term I usually use to describe them. Either a prickle, this is what this one has, little sharp prickles on the stem, or a spine or a thorn. This one is in flower or fruit right now. This one does not have any flowers or fruits on it, but it will make a little berry-like fruit. Solanum carolinense is the scientific name. This is, again, horse nettle. All right, we have another spot. We can look at 4 species or so here. Again, species that are adapted to open grassland environments. Some history of disturbance here. The first one we're going to take a look at here is this clump of grasses right here in front of me. And you can kind of maybe see with the light and the dew on the grass, it's kind of sparkling. This is, it has a little bit of a purple tint. So these inflorescences here, these structures that we see here, again the flowering structure, are really diffuse branch structures. So I can get a better one here. they're really kind of hard to see too. Very slender, branched, highly branched, and they have little tiny spikelets, the structures that contain the flowers and grasses, out towards the tips of the branches. Pretty hard to see, but maybe against my hand there you can kind of see the size of those tiny spikelets. Well, this one, the gestalt on this one is very helpful. The fact that we see this purplish tint in the light, the fact that it has these inflorescences that are very diffuse and very spreading with these slender branches, these little spikelets out towards the tip. This is purple lovegrass, Eragrostis spectabilis, another species I would expect to find in a site like this, one that is somewhat adapted to drier soils. One of the things to help separate this from anything else that would be similar is to look at the inflorescence. I'll try and get just one here. The center branch of the inflorescence, and where these branches meet, these slender branches arise off of this central axis. It's going to be hard to see, of course, without a hand lens or a scope, but one of the characteristics for purple lovegrass is there'll be a very conspicuous little dense tuft of hairs right around, again, where the branches are attached. So right at the tip of my thumb there is where these slender branches are attached to the main axis. And again, with a hand lens, you'd be able to see some little clump of hairs there. I can kind of see it on some of them, just looking at that area again without a hand lens. You can see some little hairs again clumped up right there at the junction of that branch and the central stem. So purple lovegrass. Another warm season grass, shaded grass. It is nothing I would call, a problem species or invasive. It's a good species to have, though, if you're in this type of environment. All right, let's take a look at what else is right here in front of me. Here's another native species that some of you probably know or recognize. It's all done with its flowers. This is hoary vervain, characterized by leaves that are sessile, so there's really not any petiole here at all. Leaves are pretty much sessile. The base of the leaf is attached right to the stem right there. Opposite leaves, they have fairly broadly elliptic leaves here, toothed margins. And then, of course, the flowering structure up here, which again is now showing and displaying the fruits, but several long columns of spikes. These would be called a spike because the flowers that were here were attached by their bases to this column. Remember, what happens here is the flowers, after they're done, the ovary of the flowers matures into a fruit. So now instead of seeing flowers, we're seeing lots and lots of fruits. But just this elongated central axis sticking up above the leaves like this. When it was in flower, again, you would have seen a dense row of bluish flowers here. So Verbena stricta, hoary vervain, is another species that would be characterized as a grazing increaser. Cows do not really like it. They don't graze on it, and so in a grazing situation, it gets passed up, and the grasses and other plants around it get grazed. So that is favorable, of course, to it. And that's why, again, when you see an overgrazed pasture, often you see a lot of this. So it could be somewhat of a slightly aggressive species, but it would be in a situation where there's probably too much grazing going on. That again is hoary vervain, Verbena stricta. Now I'm going to look at one here that is really characteristic, again, of this environment that we're in. Many of you probably know wild bergamot, Monarda fistulosa, pretty well, a common species in tallgrass prairie and savannas. often widely used, of course, in prairie seedings. It's a good species for pollinators. Well, this is its shorter and more drier adapted cousin, so to speak, Monarda punctata, dotted bee balm, or dotted bergamot, that grows in sandy environments. You can see it bears a little resemblance to Monarda fistulosa. Not quite the same in terms of the flowering structure. We see a series of groups of flowers at the tips of these branches here. But it has the same square stems, similar looking leaves as Monarda fistulosa, wild bergamot. But again, in species of dry, sandy types of environments. Monarda punctata. All right, we've moved around a little bit. We found a patch here of a species that truly is an invasive species, a very bad invasive species, and we haven't covered it yet, I don't believe. So this is what we want to spend a little time on talking about. It's one that you probably, most of you maybe can recognize without any problem. But if you haven't got experience with it, well, then we'll teach you a little bit about it right now. So there's a dense thicket of it right through here. It's multiflora rose, Rosa multiflora. It was introduced, many years ago as a way of building a living fence, and probably for wildlife cover, wildlife habitat, wildlife food, and it was of course, a huge mistake. So it's a rose. So it's going to be similar to many of the native roses in terms of, its flower and its leaves. Roses have compound leaves. This is all a leaf right here with its 7 leaflets. Roses also have a lot of prickles. Prickles are the sharp, pointy structures, again, that arise out of the epidermis of the stem. So again, this is one that is very difficult to move through or walk through, almost impossible sometimes. So how do you distinguish this from a native rose? Well, one way is when it's in flower. This is going to have white flowers, and the native roses always have some type of pink or rose or sort of dark pink flower. But vegetatively, there are some native roses that get this big and get this sort of sprawling, so there could be some similarity that might make it difficult for you. Many of the prairie roses are a lot smaller than this, but there are some native roses that do grow taller and more shrub size, and even get 6 to 8 feet tall, which this certainly can. So what you need to look for on the roses to really nail this down as multiflora rose is the roses have little structures called stipules, and the stipules are paired little structures that are attached to the base of the leaf, right at the base of the petiole. The stipules are considered to be a part of the leaf. A leaf is composed of the blades, which are photosynthetic, composed of a petiole, and in a compound leaf, the rachis, which is this part right here, which the leaflets are attached to, and then in some cases stipules, again attached to the base of the petiole. And in roses, these stipules are fused to the lower part of the petiole. My little finger's pointing to the stipules here. What makes multiflora rose different is the stipules in multiflora rose have these ciliate little hairs that come off of the margin of the stipules. In the native roses, you would see the stipules, they would be there, but there would not be these little ciliate hairs. Hopefully hoping that you can see those there. They're pretty obvious, pretty easy to see. You can see them without a hand lens. So all it takes is just one quick glance at the stipules, and if it has those little hairy structures there, you've got multiflora rose. And this is one that we'll talk a little bit about some of the ways this can be controlled in the webinar. All right, well, here is the wetland, one of the namesakes of this site here, the namesake, Chia Fen. So we're looking at a wetland out here in front of us. We can see a bunch of pondweed growing along the margin here, a lot of duckweed and watermeal probably out there on the surface of this wetland. It's somewhat dry. We can see there's some mud along the margin, so the water level is a little bit low. This is Chia Fen. So in some people's minds, this is a fen. This is what they would call a nutrient poor fen. In other people's interpretations, and that includes myself, I look at this and I would rather use a hydrological type of definition to separate wetlands. And because this clearly has a basin, we walk down a slope. If you look around this wetland here, we are in a basin. We are in a lower spot that receives drainage and rainwater. It undoubtedly does have some groundwater connection, but a fair amount of the water that comes in here is derived from surface flow in here and rain. And because it's in this basin and some of the other characteristics of the site, the term bog is a little bit more appropriate. Now, this is not the best one. The better example of a bog is actually a little bit further to the north. But this is a nice wetland to take a look at here. We're going to see some wetland species here. Again, I think 3 of these are native, one of them's not. So we'll start with what we see right here next to me. And the first one we'll take a look at here is smartweed. This smartweed right here. Smartweeds are a good species to find this time of year. They bloom at the end of the growing season pretty much. And this is a real easy one to identify when you look at it this time of year because of the way that the flowering structures here, the inflorescences droop like this. They have small little white flowers associated with them. If we look real close at those flowers, we can see some other good characteristics for this species, but really don't need to do that because there's enough right here to tell me that this is Persicaria lepathifolium. Persicaria lepathifolium. Another one that's blooming this time of year again, late in the growing season, and is common in these wetland environments is this one right here with the composite flowers. It's in the Asteraceae family. So it's got ray flowers and disc flowers there, all in the same head. This one also is easy to identify based on just the gestalt of it right here. This is Bidens cernua. So the Bidens genus is often also called beggar ticks. So this species has opposite leaves. Look down here a little bit farther down here. We can see these leaves are opposite and they are sessile. In fact, here's another example a bit further down. The base of the leaves are almost joined, touching each other at least right here. The leaf on this side and the leaf on this side, their bases meet right here at the stem. So having leaves that are opposite and sessile and almost clasping, basically clasping or wrapping around the stem, combined with the way that the inflorescence up here, the flower heads, are tilting somewhat and a little bit drooping. So rather than pointing straight up like this one is right here, they eventually turn and start pointing downward, somewhat downward like that one right there. That droopingness of the flower head is what the species name cernua means. Bidens cernua, again, is the scientific name for this. Nodding, cernua means nodding, and nodding again is interpreted to be the way that the flower head is bending over and pointing somewhat down. So Bidens cernua, nodding beggar ticks. This again is the smartweed, and a couple of grasses right here. So let's do this one first. This one I collected from a little bit further out there, closer to the margin of the wetland. This one is a barnyard grass. In Iowa there's 3 species, but there's really only 2 that are very common and you're likely to run into. One of them native, Echinocloa muricata, and one of them non-native, Echinocloa cruscalii. And this is another one that when I am doing surveys, I don't try to figure out in the field. I just grab the top of this and throw it in a plastic bag and take it with me, take it back home. And because really to determine for sure which species it is, you're going to have a dissecting scope so you can look at the tips of these spikelets. They're really small, of course, and it's even hard to do with a hand lens. I can give it a try here. But the characteristic you're looking for is pretty small. This one looks like it's probably the native species, Echinocloa muricata. But again, I would not trust just my hand lens. I want to take a little bit of this back with me and look at it under a scope with higher power. What you're looking at is one of the structures of the flower here. It's a structure called a glume. There's a glume, and then there's a structure called a lemma. You're going to be looking at the lemma that's associated with the flower and looking at the tip of that and seeing if that tip is firm and hard or whether it's soft and more herbaceous. So it's a characteristic that is hard to see unless you have enough magnification. But it's a barnyard grass, we know that much. And then the last one that there's a lot of right through here is this one right here, which is a really good characteristic of wet soils where we're standing right here. This is rice cutgrass. So rice cutgrass is in the genus Leerzia. The genus Leerzia, and there's a couple other species that you can see in Iowa, is pretty easy to identify as a genus. If you just look at the nodes, the node is this structure right here, this kind of swollen area along the stem. A node is where the leaves are attached. So the sheath of this leaf right here, this is the leaf blade, the sheath of this leaf runs all the way down, then attaches to the stem right here at this node. I can see it without my hand lens, but what's characteristic about the nodes on Leerzia, the cut grasses and also white grass, which would be found in forest environments, is that there's downward pointing hairs, somewhat stiff downward pointing hairs on that node. So again, if you see that on the node, that's a really good sign that you're looking at Leerzia, at least the genus. And the 2 species that are the most common are rice cut grass, found in wet soil environments, and white grass, found in forest environments. Rice cut grass is also somewhat easy to identify from the white grass by just feeling this. If you feel this with your fingers, I'm rubbing my hands upward along the sheath here, I can feel really a lot of roughness. That's because there's a lot of downward pointing sharp little hairs on this sheath. And that's where it kind of gets its name, rice cut grass, because these little downward hairs, if you were to be walking through here with shorts or these brushed up against your skin, there certainly is a good possibility that that they would cut your skin. You might be bleeding a little bit when you come out of the patch of rice cut grass. Leerzia or rhizoides is a scientific name for this one, and Leerzia virginica is a scientific name for white grass. All right, our next stop here, we decided to go into the more shaded areas here. Again, the site here is a combination of open degraded prairie, pasture grassland, old pasture grassland, and then degraded savanna areas and some areas that would be more of a forest, thicker tree cover. So we're going to do a little quick segment on the woody stuff that we see right here along this edge. So we'll start with this dogwood right here. So dogwoods are native species, of course, to Iowa. They can be considered a little bit of an aggressive species, of course, on prairies, native prairies in particular. Probably not so much of a problem on reconstructed sites, but native prairies. The dogwoods are characterized by having these opposite simple leaves and veination that you can kind of see maybe in the back here. You always see the veins a little bit better on the back. The veins that the side veins come off the main vein here like this, and then they tend to sort of curve and kind of follow the edges of the leaf a little bit before tapering off. It's going to be hard to see probably, but one characteristic that can be used is to tear the leaf and along the margin, and then look to see if in that tear you see some little threads that are connecting the veins on either side of that tear. Dogwoods will have little elastic threads that persist and join again the two broken ends of that vein. Now, so dogwoods as a whole, showing or identifying them as cornus, as a dogwood isn't too hard usually. Identifying which dogwood can be a little bit harder. Usually going to have to look at the leaf, and in this case look at the pubescence of the leaves on both the bottom and top. And based on the pubescence, this one looks like it's Cornus Drummondii, rough leaf dogwood. And it's characterized by having just a pretty substantial amount of hairs and pubescence on both sides, especially on the bottom. All right, yeah, I think this one is Cornus Drummondii, rough leaf dogwood. Right next to it here is a liana. I can separate it out here somewhat. That again, in woodland restorations, savanna restorations, you're probably going to have to deal with. This is a native species, greenbrier, that could be a problem species, I suppose, in some environments, depending upon how dense it is. A liana is a woody plant that has the capacity to climb on other plants. So it has little tendrils, structures that can help it attach to other plants and hang on to other plants and make its way up onto other plants, up onto trees. It usually has fairly green looking stems and leaves again. Here's an example of the leaves. Have some really strong veination in there. And it's going to have a fair amount of prickles. In fact, in some cases, the prickles on this species can be really dense and really thick. Greenbrier can have stems that you would never want to grasp onto with your hand because there's so many prickles. Greenbrier, and then over here, this one is a species that can be, again, it's a native species, but can be somewhat problematic in understories that have gotten just too dense with woody growth. This is prickly ash. So prickly ash is characterized by having these compound leaves. This is all one leaf right here with leaflets. One of the helpful characteristics for prickly ash is the fact that I think you can see this pretty well here if I get this in the light, is it's got two stipules. Remember those stipules we were talking about with the roses? But these stipules are modified to make sharp pointy things, and since the stipules are a part of the leaf, and when you have a leaf that becomes sharp and pointy, we call that a spine. These are spines. So two little paired spines occur right at the base of the leaf on prickly ash. Has the, again, compound leaf much like ash trees do, but again, the name prickly ash here should be a name that is used with a hyphen between prickly and ash, because it's not really an ash. It's not in the same family as green ash. Ash trees have leaves that are opposite, and we can see these leaves are not. So prickly ash, again, can get dense in the understory, but what I've seen in places where prescribed fire has been used fairly consistently, that it's pretty susceptible to fire. The stems have thin bark towards the base, and so any kind of heat from a fire is pretty effective in girdling those stems, causing enough heat to penetrate the stem to destroy the phloem tissue so that the above ground part of the plant dies. So I think with timely fires, prickly ash can be reduced if there's too much of it. But again, remember, it is native, just like the dogwood's native and greenbrier is. So they should have at least some place in a forest or woodland. Over here on this side of me, we can see some red. Well, I will say this is an oak that's in the red oak group because, again, of the bristles, little tiny bristles that come off the lobes on these leaves. So there's two groups of oaks, the red oak group and the white oak group. The red oak group includes things like red oak and black oak and pin oak. And so they have the bristle tips. Now the which one it is here, that gets a little bit harder. I'm going to look at the buds here on this one. Since they're close enough to see. And it's especially hard with the oaks when you're dealing with a smaller example, with just a small shrub, a small individual, because they're going to be in the shade of other trees generally, and that means their leaves are going to be not as diagnostic. They can be a lot larger than leaves normally would be. You can see these are leaves of an oak here as well. It looks like that based on the hairiness on this bud, and that's a good characteristic that, for black oak. If the buds are pubescent, that's going to separate it from red oak. And black oak is a species that is typically found in sandy soils. So I'm sure there's both black oak and white oak here. Maybe some red oak, maybe some bur oak too. Lastly, we'll take a look at this little shrub right down here in front of me. This is another one that could be considered somewhat aggressive and a problem in understories and savannas or in prairies. This is buckbrush. No, maybe not. I will take that back. This is a young honeysuckle. And looking at the leaves a little bit better, my first glance, I thought it was a little buckbrush, but nope. It's a honeysuckle, just a real small version of it. And I can tell that again by the shape of these leaves. These leaves have a tip that is attenuate. The tip comes out here and rapidly slenders down. So there's sort of a concave edge to the leaf right there. And then you have this tip that's somewhat drawn out. That's what the term acuminate means. And this is a really good example of what, again, a leaf on Lonicera Mackii, the bush honeysuckle, looks like. So this one is an invasive species, one of the worst ones.